So what I thought is just brief overview as well as the application areas. You know all the details in the last 4 days or 5 days. You have seen how AI ML technologies are there and how they can be implemented in the renewable energy field and the EV technologies. So we just summarize whatever things you have seen till the last 4 or 5 days. We'll see the basics of the AI ML and what are the application fields we can get in the energy and the EV technologies. And then we'll see the case study. So basically, this presentation will be on case study oriented, the application field where we can implement all these things, the basics, the details, as well as uh, the areas of the renewable energy, how we can go further. That's why the subtitle I have given here, Unlocking the Future of Sustainable Energy. So using both the technologies, AIML as well as the renewable energy and the EV technologies, how we can unlock the future of the sustainable energy. So that will be basically the theme of this talk. And let's make it interactive, because if I will only speak and you will be listening, so it will be kind of boring. So in between, we'll do certain exercise kind of thing. I will share the Google form with you. So there are certain questions, kind of quiz will be there. So it will be more interactive, as well as when we will proceed with the talk, we'll be discussing. So there will be one case study. I'll give the basic details. So we'll discuss, and then we'll have a brainstorming session kind of thing, because you are already having the knowledge of AI ML and renewable energy technology, EV technologies. So basics, I'll just refresh it, and then we'll have the brainstorming discussion so that it will not be a boring session. Okay, so is that fine to everyone? We'll start the session. So from the title, you can see we are having three terminologies, like what is AI, what is ML, what is renewable energy, and what is EV technologies. Then, like I said, we'll have the application as well as the case studies. So basically, I designed the slide like that. Only application part and the case studies will be there. Then we'll see the integration of AI ML with the renewable energy and the electric vehicles. So combinedly, we'll see how AI/ML is going to be integrated with both renewable energy and electric vehicles. Separately, first we'll see, and then we'll see the integration of all the three terms. Then we'll see what are the challenges. Basically, it is providing certain benefits. Those benefits also we'll discuss. And after that, we'll go for the challenges and consideration, and then the discussion part we'll see. So that is the outline, and these are the objective of this talk. So first, basic parts you already know what is AI and ML technologies, and in detail I'm not going to discuss. Like there are multiple models are there, multiple algorithms are there. We'll go for detailed discussion. Each model will take 1 hour and 1.5 hours. So this is not feasible for us. So we'll see the basic concepts and how we can implement the AI/ML technology. So that is the understanding of AI/ML. Then we'll see the gaps of the renewable energy and the EV technologies. And then we'll go for the integration of AI/ML in both renewable energy and the EV technologies. And we'll see the real life examples and then find out the future research direction. So basically here we'll have the brainstorming session where we'll discuss all the future research direction and how to overcome what are the current challenges present in these fields. So these are the objectives of this talk. And basically, you'll see in my slides, mostly the pictures will be present, because theory-oriented writing it will be boring. That's why majorly the pictures. And all these things I'm going to explain in brief, not in detail. So wherever if you have any doubt, you can please raise your question, and I'll able to solve it. Then I'll be happy. Otherwise, we can discuss and find out the solution for that. So from AI, this is artificial intelligence, and when I was in BTech, that time the first time I heard the artificial intelligence, and we are having a subject on that artificial intelligence. There, I found out all these things like how machines can think, how humans thinking procedure is going to be implemented inside machines, and that time it was the research oriented direction that time only, because implementation was not quite good. But nowadays, if you see every product, whatever is available in the market, minimum artificial intelligence is present. If you go for your air condition, your refrigerator, your cars, everywhere the artificial intelligence is involved. So that is basically, if you summarize artificial intelligence, that is the machines which is going to think and act like humans. Now the research is in very high or advanced stage, where machines are getting the input from the environment, and then they are analyzing the situation. Situation means the environment. What are the things happening in the environment? And accordingly, they are going to act. So the programming inside the machine. So basically, the chips present inside the machines is like that. Multiple chips are there. All those chips are having the programming, and they are communicating among themselves. So, for example, if I'll give you the example of the your basic robots are present. So basically what the robots are doing, they are finding out the situations present in the environment. Then suppose one chip or one sensor is there, the eye sensor of the robot, which is going to see what is the environmental condition present. Then it is taking those pictures. So because cameras are installed in the eye, so it is going to take the picture, and that picture as the input to the programming present in one of the chip. That chip is going to decode the image, or you can say find out what are the inputs present in the image, and those decoding information is forwarded to another chip. So between multiple chips, there are communication protocols present. So if there will be any kind of disturbance is happening inside the communication protocols, also the chips are not going to respond correctly, or there will be the output is not as predicted. After the communication between this, the other chip is going to evaluate the situation. So if the your microwave is on, for example, your microwave is on, and robot is finding out that for 5 minutes, or let's say for 10 minutes it is on. Now we need to switch off the microwave. So taking the image itself from the environment, it is analyzing for this kind of food how many or what is the time, what is the cooking time. So inside the programming, the threshold limit is set. So for example, you are heating a product, maybe 1 minute or 2 minutes is enough. So in the threshold value, that 1 minute or 120 seconds is mentioned. Then when the picture is coming to the chip, it is analyzing and finding out whether the value is less than the threshold value or not. So if it is less than the threshold value, then it is giving another stimulus response to the hand of the robot. The sensors present in the hand of the robot to switch up the microphone. So this is just a raw example how the artificial intelligence is working, because machines are going to take the input as well as they are analyzing it and providing the output to the environment. So if you go for the IoT or your Internet of Things, basically it is working like that. Hardware devices are there, and those devices, basically the sensors and the actuators, they are taking the input, and the chips present inside the hardware devices, they are analyzing and providing the response or through the actuators to the environment. So that is basically one kind of artificial intelligence. We'll go for example of your agriculture field also, how the sensors are getting the temperature, the humidity, as well as the soil condition. So n number of projects are happening in both combination of artificial intelligence as well as your IoT field. So that is we'll just see the example of that. But basic our aim is to find out the renewable energy field, how the artificial intelligence is going to work. So here you can see certain terms are mentioned like weak AI, strong AI, narrow AI, then the super intelligence, the machine intelligence. Basically, this super intelligence field is not developed yet. It is under research. And if you go for weak AI and narrow AI, basically these are the alternative terms for a particular set of inputs. Both will work. And after that input, if some other kind of inputs you are going to provide, then these fields are not going to work. But strong AI, in other words, it is going to find out, you can say there are millions of inputs are given to the training, and then whatever may be the situation, it is going to respond to that. Machine intelligence, the example we have seen in the robotics, how the machine intelligence is working. So these all things are coming under the artificial intelligence. It is a broader view, and the machine learning is a part of the artificial intelligence. We cannot say that both machine learning and artificial intelligence are same, because machine learning is a subset of the artificial intelligence, and inside machine learning we are having concepts like your supervised learning, your unsupervised learning, reinforcement learning, deep learning. All these things I'm going to give you the overview, how the supervised learning is working, how the unsupervised learning, reinforcement learning, and deep learning. So those are working in this field, they are uh, acquainted with all these terms, and the research basically happening not in the core fields of this as well as the integration fields of this. So if you go for the artificial intelligence application field, you will find out the supervised, unsupervised reinforcement as well as the deep learning field, or sometimes you can say it is the fusion kind of thing. We can combine all these fields in our application and find out how the variation of the output and input is happening. So this is just an overview of AI and ML, and the definitions is already written, and you must have gone through what are the artificial intelligence and how it is going to work. So we are not going to discuss all these things. Better we'll go for only the application point of view. So problem solving is there, perception is there, language understanding like your natural language processing. So how the human languages, there are billions of human languages are there, and how you are going to interpret it into machine, and machine is providing the feedback for that. So that is the language understanding, and the decision making we have seen already the example. So these are coming under your AI field, and the key components of the AI field are your machine learning, your deep learning, your neural network, your natural language processing, your computer vision, and the cognitive computing. So cognitive computing is the you can say the higher stage of all these things I have mentioned here, like machine learning, deep learning, and neural network. These are one areas of research, or we can say one field what we are going to implement and find out the output. But cognitive computing basically comprises of all these fields. We'll find out the implementation of machine learning. It will have the implementation of computer vision, NLP, neural network, as well as deep learning. So this is basically the highest stage of the AI. So we'll see all these things in example, how actually they are going to provide their impact on the renewable energy field and in the your EV technologies. So machine learning, we are having the algorithms which are going to train the model as well as will predict certain decisions. So that is the just you can say the outline of machine learning. But basically, how machine learning is working, you are having certain input, or you can say if you go for your implementation point of view, you are having data sets present, and all those data sets are having different parameters. There can be thousands of parameters, there can be hundreds of parameters, or there can be one or two parameters. That depends on your application, how you have collected the data. So all those data sets are having parameters. Each parameter is considered as a feature, and then those features we are going to train. So how you are going to train? There are models present. Using each of the models we are going to train. So for example, if I'll give you your biometric. So all of you have gone through the biometric evaluation, biometric recognition. So how it is going to identify that it is your face only, because your face is having multiple features like your eye color, your facial conditions, whether the face is round or oval or something, the nose direction, or how the lips are there. So all are the features of the human face. When you are going to provide an input, that is a training data you are providing. Suppose one university is having 10,000 employees. Each of the employee is providing their data. That means the training is happening, or the data set is now collected. So everyone's feature is different, and then it is going to train the model, the machine learning algorithms are there, and those algorithms are going to train your data set, taking all those 10,000 inputs, then finding out whenever you are going for testing. So what is the case of testing? When somebody is coming and showing the face, it is giving you whether it is correct person or incorrect person. So that is the testing phase. So machine learning is basically working like that. First, you are collecting the information in the form of the data set, and where each parameter is a feature. Those features are going to be trained using the machine learning models and algorithms. And here also two terms I'm using, like models and algorithms. Both are different. Both are not at all same. Model is the mathematical model. Using those mathematical model, we are creating the algorithms in machine learning. So what is the model? Model is already present in mathematics, because computer science is only the branch of mathematics. So already all those models are present, like your regression model, your classification model. So all these things are already present. We are just taking those models and reforming the algorithms out of those models. Then those algorithms are going to provide the features and taking the inputs from the features, and then finding out whenever the test case is coming whether it is matching or not. That is the basic idea how the ML is working. But if you go in detail, we'll have the three things, like your supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, like I said, the trained or the labeled data set is there. So what is a labeled data set? If you are having three features, then I am providing that combined with these three features, if the output is matching with the combined three features, then I am providing the label as suppose 3. And if it is matching 50%, the label as 2. And if it is not matching any, then label is 0. Like that, the labeling is done under data set. So that is the supervised learning. And the unsupervised learning is basically it is finding out the pattern, or you can say the pattern recognition is coming under your supervised learning. It is finding out how the pattern is changing. There is no 0, 1, 2, 3 values are present in the data set. So it is finding out the patterns, and then it is training and testing the model. And reinforcement learning, it is basically interacting with the environment. The example we have seen for the robotics, how the robots are acting according to the input of the environment and then providing the output. So basically in three, you can say three distinct features it is going to work: supervised, unsupervised, and reinforcement. The basic one is supervised, and the highest one is your reinforcement learning. And these are certain features like key concepts, how it is working. Already we have discussed this, your training data and how the features are there, what is model, what is algorithm. And two more things are there: overfitting and underfitting. So those are working, they must be aware of these terms, how the overfitting of the model is done. So overfitting means you have given enough training data, and it is also considering your noise present in the data, and it is a kind of generalized fit. So that is the overfitting. Underfitting, it is very simple to capture. So basic features are there and the data set is very less also. That is the underfitting condition. But we don't have to go for all these two terms, because overfitting is not good as well as underfitting is also not good. So in between you have to test, and you must be knowing that 80% and 20% rule is there. Training, you have to give 80% of the data set, and for testing, you'll go for the 20%. That is the healthy environment in case of the machine learning. And finally, the validation and testing, how you are testing your model's performance depending on multiple case studies. So these are the basics. And another term I have given here is deep learning. So basically, deep learning is working using the concept of neural network. Neural network is basically your human brain cells, how the human brain cells is working. The same concept as given in the neural network, and deep learning is basically taking the input and output for the deep from the neural network, and basically it is used for your image recognition, your natural language processing, and speech recognition. So neural networks, we are having the neurons, which are your input, and then layers are present. So neurons are given input to the layers, and each layer we are having between the layers and the neurons, there are weights present, which are called the connections, and activation functions are present, which is going to find out the output. And then we are having multiple types of neural networks. So application field of each of the neural network is different, like your feed forward, your recurrent neural network, convolutional, and general adversarial, and then another one is their autoencoder. So these are the different kinds of neural networks, and these are the features. So in detail, we are not going to discuss, just a refreshment of your knowledge, how what you have already studied in the last 3-4 days. Activation function is basically giving you the function applied for the output. Then there is a back propagation. Whenever the weights are trained, we are finding out the output, and that is not our predicted output. Then we need to go back and again train the model. That is your back propagation algorithm. Loss function is basically how the predicted and actual output differs. So that is calculated by the loss function. And regularization is whether it is overfitting or underfitting. And then optimization algorithm, when we are doing the back propagation, we are finding out the better output than the previous output. So that is your optimization algorithm. So using all this concept, the deep learning is basically working. And this slide is your data science and machine learning. So you have heard about data science, you have already heard about machine learning, but both are different. Data science is a kind of superset, and machine learning is just an implementation area of the data set. So data science, we are going to using data engineering, data visualization, statistical understanding, and to get the output of all these fields, we are using the machine learning. And here also we are using the 3 fields that we have already seen. So visualization is done through the data science, and for the real impact of the real life field, we are using the machine learning algorithms. So this is just an overview of your machine learning and AI, and how the deep learning and neural network is working. Now we'll go for your renewable energy. And you already know what is the renewable energy, and this diagram also I have given how the non-renewable energy and the renewable energy is different. And renewable energy, basically it is nowadays requirement, because all of you have seen the temperature increase during this summer, how it is very high. So for that, need to take certain measures, and so one of the measure is using the renewable energy instead of the non-renewable energy, because it is going to provide its input for the temperature increment. The example we have already seen. So this is just the overview of your renewable and non-renewable energy, how they are going to work. So all of you know, basically the renewable part is going to be recycled, and non-renewable part is not going to be recycled. And the importance of the renewable energy in the sustainable future is you're reducing the carbon emission. It is cost effective also. It is creating the jobs in the industries, and it is providing the energy security, environmental benefits it is providing, and this is the best option because it is recyclable. So now coming to this one, the job creation. We have already seen, actually last week we had a discussion like whether AI/ML is going to replace the human beings in every industry, or maybe in academia also, because teachers, whether they are going to be replaced by your AI/ML or not. So how in this field this job creation is coming, because we are finding out the implementation of AI/ML in the renewable energy. So basically it is going to reduce the job, but how the job creation will be there. So I'll give you one example. Suppose you are working in the power plant, and you have taken the AI/ML concept, like it is finding out or it is detecting the anomalies present. It is finding out the temperature of the power plant when it is increasing. There is a signal to the environment that you need to reduce, or any other kind of application you can go for that. So there we are providing the smart function, or we can say the machines are going to act intelligently to find out the output. But who is going to work there? The machines, basically, if you will say that the robots we can put there, and the robots are going to work. But how the robots will work? Who is going to supervise the robot? There is a chance that another robot you can implement for the supervision, but anyhow there need a human intervention to you can say supervise the robots, or to find out the correct output, because machine is just a learning feature. Whatever the inputs you are going to give, accordingly it is going to learn it and act. But when it is coming to the human introspection or the perception of the human, machine cannot do as good as human. It is better to remember. It is better for the machines to remember things. Human cannot remember as the machines can remember. But whenever it is coming to the environmental input or output, or you can say the response kind of thing, human is going to provide the better response than the environment. So in that way, we are going to find out the job creation in the environment, and other terms basically we know how it is going to work. Another term is coming the predictive maintenance. So what is the predictive maintenance? It is like maintenance strategy of our data analysis tool. So previous slide we have seen the uh, this one, the data science and the machine learning, how they are different. The data science is the broader, and we are implementing the machine learning to find out the data science features. So in case of predictive maintenance, basically we're using all the tools and techniques present to proactively maintain the strategies. You can see this diagram. We are having four stages when you will go for any kind of maintenance. First one is your reactive maintenance. So something is broken, you are going to fix that. That is your reactive. Or some uh, or you can say there is some problem, we are just after happening of the problem we are going to fix it. Then periodic, it is the schedule maintenance, and proactive is it is going to eliminate the problems at the early stage, and the final stage your predictive, before happening of the event we are going to predict that. So in case of the implementation of AIML, if you go for the renewable energy field, basically this predictive maintenance is required because we are having very less amount of resources present, and it will not predict in hand what are the output of this renewable energy utilization, or if you are going to waste this renewable energy, then the predictive maintenance is the only solution we can provide in this thing. So that's why we'll go for this predictive maintenance and use the machine learning tools to find out the failures or the problems before they can occur. And the goal of is to schedule the maintenance activities at the most cost-effective time, minimizing the unplanned downtime and reducing the maintenance cost. So this is just the you can say the definition part, but the basic of the predictive maintenance is how we are using the AIML technologies to analyze whatever the environmental conditions are present and finding out beforehand how we can control the situation. So that is the predictive maintenance, and this is one of the major technologies used in the renewable energy field using the AIML to save the renewable energy resources. So this diagram, yes. Any question? So this diagram basically is providing the predictive maintenance example, how we can go with the predictive maintenance using AI and ML. So basically two boxes you can see here. One is your physical, another one is your cyber field. So physical, all those hardwares are present here. Those are generating the data, like your sensors are present, your machines are present inside this. And the cyber world is basically how we are going for the techniques, the tools, and the terminologies, the technologies present. So machine learning, your data analysis, data science, everything is coming inside the cyber world, and cloud we are going to basically store that. So why I have kept this slide, because we need to see the integration, because maybe majority of your field is from electrical, so you know how the machines are working, how it is taking the input from the environment. And as my field is coming here in the cyber field, so taking the input, like we have already discussed the data set creation. So your task is to design the data set, and once you have designed the data set, now our work is starting here. How we are going to implement, or how we are going to analyze the data set and finding out the correct response from the data set. So one of the response is the output again to the hardware field. So basically, I'm working in the IoT field, and there I'll give you one example. In the labs, basically, we are designing your smart traffic system. We are designing the smart agriculture system. So how it is basically working? There are multiple sensors are present. If you go for the traffic light, one of my students, they have designed the rail as smart. Going to the stations, you will be, and or you can say there is traffic present in the railway system, and during what time it is going to be present. So the train is approaching to your station, or you can say there are apps are present which are showing the train's movement. Now it is going just 10 minutes or 15 minutes, or sometimes I have also experienced maybe behind from my station, but it is showing the station. So that is how it is working. But in case of IoT, we find out the exact input through the hardware devices. Is here how the machines are going to collect the data. There should be error or any noise present. If there is attack on the machine, definitely there will be error. Whatever the data you are doing, you are going to just erroneous data. Your task is to eliminate the error and provide correct data, so that we analyze in the cloud and find out analysis like your data mining or machine learning features, all those features what we have discussed, and find out the results. So directly sometimes that analysis is provided to showing the output, or sometimes is finding out the support system or the final result or this scan. Like in the predictive maintenance we have seen, we are going to find out how this also again gives to the visualization application, or you can say your output terms. So these two, the analysis support system providing your response to the environment. Here, the physical world is taking the input as well as providing. Behind this physical interaction is your cyber world. So all of you must have I have given the analysis is possible, so that the maintenance in hand can do, or in future we can predict this can happen. So through examples of your Google's and Google's certain examples are there where Google is going to predict future wind condition. So for three, and now we are analyzing those to provide day what will be the wind condition. Like you have seen temperature, how this things ahead. This is kind of your recommender system which is going to provide the output. Cyber world and the physical world, when they are taking the this is because beforehand we what are the renewable energy sources are there, and how we can for the analysis they predict your water is this is, and we can utilize in this case if into those to more than 1 year or 2 year, like that. So that is the prediction of the decision support system or the recommended system which will be implemented in the future. So that is the basic idea of the renewable energy field, using the predictive maintenance, how in future you are going to implement. So regression model is there. Or, yeah, basically in this slide, I'm going to discuss that. What are the techniques we are utilizing in the predictive maintenance? So data sources, like we have discussed, we are having sensor data, we are having the IoT devices data, and the history of the maintenance record. So for a particular river, this water is utilized in 5 fields. Suppose in 5 fields, water is utilized, and some of them are contaminated through certain procedures, or due to certain conditions it is contaminated. So that is your historical maintenance records. So using all these input we are taking from the environment, we are finding out the current condition, and then what is the historical maintenance record. So these three will be the input to the AML technologies. Then we are having certain algorithms, like we are having classification algorithm, where we are having binary classification, multi-class classification. Those are working in machine learning field. They are aware of classification. The levels 0, 1, 2, 3, those levels. Binary classification will lead 2 levels, either 0 or 1. That's why the name. Multi-class, you are having more than 2 classification. With linear regression and linear regression, it is point wise. We are finding out the output, and time series over a continuous. So this is the classification 2 kind of models. In the initial slides, I told you algorithms and models both are different. Both are not at all going to be similar, because using the models we are generating the algorithms. So models are basically your survival analysis models. So Kaplan-Meier estimator, Cox approximation hazard models. So these are all the mathematical models already present in the history. We are just taking those models, and according to the environmental condition, we are making, or you can say we are designing as algorithm, and those algorithms we are providing. So ensemble models, basically it is combining multiple models outputs, like your random forest, your gradient boosting machine. Recurrent neural network, or LSTM. LSTM is basically memory oriented. Where you are going to store something and then recall from the memory, then you use the LSTM. And reinforcement learning, from the environment it is learning. So it is, you can say, a trial and error method, or you can say the first input is like suppose X, and from the X we are gaining, suppose X just we are, and then how the Y, the output of Y, the impact of X and X dash on the output Y. So that is your reinforcement model learning, and the Q learning algorithm is basically used inside the reinforcement model, and combining multiple ensemble models, teacher. So that is the feature fusion, multiple data set feature you are combining to find out a particular output. So that is the hybrid approach. So in case of predictive maintenance in the renewable energy field, basically these 3 things we are going to implement. Techniques. We'll use the supervised learning in case of and your unsupervised learning in case of multi-class. We are having the regression models for the time series and the linear forecasting. Then again, we are having multiple models, like we combine the input of multiple classes to find out the output. And this is the feature fusion in the hybrid approaches. So these are the basic overview, but it will go in detail how the classification are, how these hazard models are working. There are mathematics involved in each of these models. We are having certain equations present in the estimator in the hazards model. Using those equations, we are going to calculate. So all these equations basically comprising of activation function, input, and the output. So according to the environment, how we are mapping those equations in our condition. So whatever the input condition, you can say, suppose you are going for the wind prediction. In case of wind prediction, what will be the input? It is a time series forecasting basically. So that input we are taking and in the equation we are putting, then activation function is basically what the equation is, and then finding out the output. So this is how the algorithms and models are working in case of the wind prediction. Similarly, if we go for the solar energy. So in solar panels, the energy, you know that the sun's rays are different in different time of the day. So morning it is very less. Then when the day is approaching, it is going to increase. Then in the afternoon time, it is again decreasing, and it will be very less at the evening. This is a time series of data. How the solar light is fluctuating. Using that time series of data, we are finding out the deep learning models, or we are providing the input as the time series data of the sun. Then the model is finding out from one layer to another layer how there is a deviation in the that tomorrow what will be the condition, or you can say after 10 days what will be the condition. So basically these things are working like that, how you are taking the input, we are finding out the output there. So basically these two are the examples how maintenance is done in the solar plants. So you see here we are having the inputs in the right hand side. You can see here it is written the SCADA. So SCADA is basically a communication protocol. Hardwares are present here. This is also one hardware, that is your solar panels. So how the data is transmitted to the solar panels through the basically the protocols or the communication protocols. So SCADA is basically the protocol which is going to be implemented here. So sensor data is basically the vibration, the temperature, the current, the wind speed, and operational data is how in time interval the data is going to change, and status data is basically the activation or deactivation. So everything as input is given to the solar panel. Then the panel, inside this panel, whatever the models we have seen here, the classification model, or according to the situation it is going to be implemented. Like in this case it will be a survival analysis model we are going to implement, and the analysis is done here. Then it is going to provide you the output of pattern, like in case sunlight prediction, it is providing a pattern only. That's 6 a.m. It will be, this is the temperature, 12 a.m. This is the temperature, and evening this is the temperature. So if there is failure, like wind is very high, or you can say clouds on the sky, then how this pattern is going to be varied. So that is also the type of thing it is providing us input. So this is how the predictive maintenance is done in the renewable energy, and this is the power plant. The below diagram is for the power plant, how the inputs of boiler fed is given, and then how the monitoring the IoT devices are doing. And then here all the plants are running for the money. If there will be loss, they are going to shut down the plants. So that's why the major impact of the monetary benefits is also associated with all this renewable energy. If there will be loss, nobody is going to do whatever the measures we are giving from the AIML, or whatever the measures you are giving from the hardware point of view, it is obsolete. Nobody is going to use. So for getting the monetary benefit, we have to implement all these technologies and finding out better environment condition, as well as the prediction will be done. So these two are the examples how the predictive monitoring is done, or if predictive maintenance is the renewable energy. So this is another example, the smart grid management, how you are going to implement the smart grid. So here basically we are going to implement the data analytics, the machine learning, the IoT technologies to monitor the electrical grid components, like uh, the failure can occur at what time, or what is the safety measures need to be taken for the power supply, or what is the efficiency of the power plant, or the electrical grids are going to provide, whether it is reliable or not. So all these things are the output of the predictive maintenance. It will implement the same in the smart grid. So this is one diagram which is basically showing how artificial intelligence and computational intelligence both are working in the smart grid environment. So here we are having the data filtering and the processing options, and then we are having the energy management control and optimization. We can do basically if there is any kind of efficiency measures are there, then we'll go for the optimization kind of thing, and then we can have the modeling and the monitoring. So suppose certain kind of output you want, then you can prepare your model accordingly and then monitor how the output is coming from that model. So that is the modeling and monitoring term. And artificial intelligence and computational intelligence is basically, we have already seen what is artificial intelligence. Now coming to the computational intelligence, it is taking the features of the artificial intelligence as well as other features of computation it is adding there. So you can see here the examples are given: fuzzy logic, artificial neural network. So fuzzy logic is different, or you can say the computational model present. We can combine the artificial neural networks with the fuzzy logic to find out the computational intelligence. Okay, so this is example of your smart grid, and this is how basically the AML application is working in the smart grid for your load forecasting, demand response, and energy management. On the smart grid. So sensors are basically just one or two line. I'll give the overview how the cybersecurity is done because it is related with all the grids components. So attack, or you can say last 2019 or 20 around, there was an attack, Stuxnet attack happened. So that is basically a cyber attack.
Madam, your voice is breaking in between sometime. Hello?
Generator and storage. Yes.
Hello?
Yes.
Madam? Yeah,
Hello.
I think
Yes, sir.
your voice is breaking in between.
Okay. Is it audible now?
Yeah, yes. Now it's not a problem. Yeah.
Okay. 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 So basically, I have worked on the cybersecurity part. So you can see here in this diagram, you are having all these hardware devices which are basically collecting the data or analyzing the data, the power generator, the smart home grids. Cyber attack can happen all these fields. Attacker can inject their attack and change the data. So suppose in case of your storage, whatever the data you are storing in the power generator is generating and you are storing the data, that can be changed due to the cyber attack. So how we are going to prevent that? We'll apply the AML application to predict. So suppose this is my trend, like we have seen one of the slides, historical measures are also required. So we'll go for the log data and we'll check what is the pattern of this power generator. So for example, if it is providing from day morning to evening, the records are maintained. So every time of the day, what is the storage capacity or what is the data is generated from this power generator, and if there is a certain fluctuation is happening in any time of the day, then that is a major concern. This is just one example of the power generator. Similarly, if you go for your smart meters, so smart meter records, your readings can be tampered through the cyber security. So basically, our team worked on this, the providing or the anomaly detection inside the smart grids. As well as the communication between these devices, because every device providing its input to another device, and that is also going to be analyzed and the output is given. So the communication between all these devices need to be secure. So our task is providing the security to both the hardware devices as well as the analyzing software or the communication protocols present there. So basically, I have worked on this one, cyber security, and you better know how the grid monitoring and maintenance is done, because I have less exposure to that. And then demand response energy management is done. So all these AIML techniques can be implemented all these application field of your smart grids. So these are certain issues mentioned here, and then how we are going to implement the machine learning and the AML techniques there, and what are the output of the implementation, which kind of prediction we can do, or the forecasting we can do. So load demand forecast we can do. So it will go for the load forecasting. You can save the machines. If there is a breakdown is going to happen, we can save the machine from that if there is a load forecasting is done. Similarly, other outputs or forecastings are given here, like attack detection I have worked on, and future trends and patterns also it can generate. So this is basically the combination of both the hardware as well as the software techniques to provide security, safety, and maintenance to the smart grids. This is one example. And there are certain case studies I have listed out here. So basically in 2024 or in the current situation, these are the case studies the companies they have developed for the renewable energy. It will go for Google's DeepMind. The project name is this one, Google's DeepMind and wind energy. They are basically predicting the winds, or you can say the direction, or how much energy you can provide, or which field or which part of the globe we are going to uh, get more wind energy, and from that we'll go for the sustainable energy creation part. Similarly, the Tesla has given the energy storage. Basically, they are working for the energy storage. Google is for the prediction part. Tesla is for the energy storage. Once the prediction is done, how you are going to store that energy for the future uses. Then IBM is also working on IBM Watson and solar energy. So basically, this is for wind energy, this is the storage, and this is for the solar energy prediction. And other companies like Siemens, Gamesa, and wind turbines, then NG and AI for the energy management. These are the names of the projects for predictive maintenance in the renewable energy field. And then this is Ørsted and offshore wind farms, NL green power and AI in hydropower fields. So these are the case studies. If you go and search in the Google, you will have the document of 1,000 pages, how they are working, what are the technologies are going to be implemented there, and which part of the globe they have implemented these things. We can check that. And this is one case study, the AML in predictive maintenance for the wind turbine. So basically the background is given and what we are going to do. The objective is also given. So you can try this. I will share the slide with sir so that sir can forward you and you can try this case study. Which kind of, so basically objective is your maintenance. You can check here. Optimize the maintenance schedules and enhance the overall efficiency of the wind farm. So we need to find out which kind of technologies you are going to implement. Like we have seen the models and the algorithms, and what is the output. So if you are going for the regression model, why regression is important here, and how to achieve the regression model or design the regression model taking all these backgrounds. So that is you can do this one. And these are the startups companies available for the renewable energy field using the AIML. So these are the 5 startups, and other than that, also 600 renewable energy startups are working nowadays in the globe, and the locations are given where they are present. This is just for the information how we know that many startups are working for the same field. Okay, so first part, I think we have completed the renewable energy field using AIML. Second part is our EV technologies. So with this renewable energy and AIML integration, if you have any questions or you want to discuss something, then we are open for the discussion. Uh, Otherwise, we'll go for the next part.
Hello, good morning, ma'am.
Good morning.
Ma'am, thank you for the presentation,
Yes.
ma'am. I have, ma'am, a
Yes.
basic question, ma'am. As to describe the ma'am regularization and these like overfitting and underfitting. Ma'am, kindly please
Yes.
can
Yes.
you explain it?
Yeah. Okay. So basically, let me go to that slide for yeah, this is the slide, overfitting and underfitting. So overfitting is basically, suppose you are having a data set, okay,
Yes.
and you are having input of suppose 1,000 data are present. So 1,000 data, each row, if I'll give you the example of your Excel sheet, suppose you are storing the data in the Excel sheet. Excel sheet is having 1,000 rows filled with data, and the columns are the features. Okay, so suppose you are taking one feature, facial recognition. I'm giving one example. So one feature is eye color. So in one column you are storing the eye colors. Okay, another feature, suppose you are providing your you can say your hair. So whether it is curly hair or it is straight hair or it is a kind of mix, so that is another feature. Okay, so in case of overfitting, instead of 1,000 data, suppose you have given 1 million data. So 1 million persons data you are fitting with eye color as well as your hair texture. So then whenever you test case is coming, test case means suppose some person is inputs like the hair is your curly, eye color is black. So out of 1 million, maybe more than half million people are having the same feature. Yes or no? So
Yes.
overfitting. It is going to find out that this is one person, but it is correct because half million people are having the same feature. So it may not be going to find out correctly the person hair is curly and some and is curly, and we all 10 people are having the eye color as same. So if I go for this kind of feature, then for all the 10 people it is going to identify single people, right? Yes or no? So that is the wrong perception or prediction we are doing here. That is coming under your overfitting. When you are providing interest, all the test cases are coming under the training case. So that is called your overfitting. Is it clear?
Yes. Yes, ma'am. Thank you, ma'am.
Okay. Yeah, and underfitting is basically the reverse case when you are providing very less amount of data. Instead of providing 1,000 data, suppose our suitable case is for giving 1,000 data. Instead of 1,000 data, if you are providing 10 data, sometimes it is not going to identify because you have not provided enough data to train. So sometimes it is showing not identified. But why it is because this feature is not inside the training data set. So that is coming under your underfitting of the data. And to identify, we are having all these this feed forward network and these two are used for this kind of underfitting and overfitting. And images you are using the convolutional neural network. So CNN is basically for the image part. Yeah.
Yes. Yes, ma'am. Thank you, ma'am.
Any other question? Okay. Don't there basically, and just need to check like whatever you have this is fruitful to you or not. Is
Hello. Yeah.
Sir,
So, audience, do you have any other questions, queries? Yeah.
okay, sir, I'm sharing in the chat box so that people can find out.
Yeah.
Uh, Ma'am, do we need any devices like a Raspberry Pi to communicate microgrid with Ethernet in real time?
Uh, yeah, you need to, like, if you are going for the simulation kind of thing, then you need the Raspberry Pi board or Arduino board for simulation purpose, I'm telling. And
Okay.
if you'll go for working in real examples, so in real power plants, they don't use the Raspberry Pi. They are high because they better know that what are the devices present. But for simulation, we have done the Raspberry Pi.
Okay, ma'am.
Just a minute, I'm sharing. Okay, I have shared in the chat box. Please check the Google link. Google form link is given and tell me whether it is accessible or not.
Madam, do you want us to give any?
Sir?
Do you want us to give any permission?
No, no,
Nothing.
not required. But it is not visible in the chat.
Oh, I think one question someone asked in the chat box.
Is AI and computational intelligence different?
Sir, did you get the link?
Hello, ma'am. There is one
Sir,
question in the chat
link?
box.
Wait. Yeah.
Yes, sir.
Ma'am,
Hello.
we could not be able to get any, Google link in the chat box as you mentioned. Can you confirm whether you have shared it on the chat box?
Oh, yeah, I have shared.
Okay, but it is not visible to us at this point of time.
Um,
Otherwise, you can just send that to Professor Manoranjan. We will be sharing at our end.
okay. Okay, I'm
So,
sharing.
meantime,
Meantime,
okay,
we'll start.
meantime, there is one query into the chat box. Is AI and
Okay.
computational intelligence different? So, it's a question from one of the participants.
AI and
Computational intelligence.
yes,
Is
both are
AI
different.
and
Like you have,
computational intelligence different? Yeah.
yes, both are different because AI is having its own setups and computational intelligence will have certain mathematical models along with all the AI features. So you can say computational intelligence is the superset. In between that, AI is coming. So we'll use all the AI concept in the computational intelligence and then we'll go for whatever the input output you require. Okay, so I have shared the link with Sir Manoranjan sir. Sir can share, and we'll again start the second part. In between that, you just go through the link, and 5 questions I've just put whatever we have discussed. Check that.
Okay, we'll be sharing that one.
Share my screen. Yeah. Let me share my screen. Yeah, is it visible, sir?
Yes, ma'am. It is visible. Yeah.
Okay. So first part we have covered the AIML implementation in the renewable energy field, and the second part of the talk is your electric vehicles. So you know what is the electric vehicle and how it is working, its internal details. So I'll just uh, discuss how AIML is going to uh, work with the
कॉपी करके डाल
electric vehicles. Okay, so this is just showing you the evolution of the electric vehicles. How from 1769 the electric vehicles started, and what is the condition till 2020, and how it is working. What is the internal details that you better know. What is the internal details? I will discuss how in electric vehicles we are going to implement the AIML part only. Okay, so this is the current market trends for your electric vehicles from 2020 to 2030, how the electric vehicles are going to increase. So battery electric vehicles and plug-in hybrid electric vehicles. So both are different, and the use of the battery electric vehicles are more rather than the plug-in electric vehicles. So details you already know, and you better know than me how the electric vehicles are working. So details we are not going to discuss here. The internal details of the electric vehicles. Rather than we'll discuss uh, how we can implement the AIML in the electric vehicles. So the basic part of any electric vehicles is your battery management system, because through which it is running. And we'll see in this slide the importance of the battery management system in the EVs, because it is providing you the safety, the performance, the longevity, cost efficiency, and the user experience. So thermal runaway it is providing, and safety options, then optimal efficiency, maximizing the range, and reducing the maintenance cost, extending the battery life, providing the real-time information, and manage the charging part. So how in BMS we are going to implement the AI features here? And the BMS is having the AI feature as the advanced feature and the innovation. So these are the basic operation of the BMS. But for the advanced feature, we are going to implement the machine learning and AI inside the battery management system, and will integrate with the overall vehicle systems as well as inside the communication protocol, and finally it is going to provide the scalability to the BMS. So in the latter slides we are going to discuss how it will be integrated and how the overall vehicle management is going to be done. So basically the key applications of AI/ML in the BMS is this 5. So in these 5 areas only we are going to implement the AI/ML in the BMS field. So first thing is the state of charge estimation. So till what time the battery charge is there, and after what time there will be no charge. So basically, if you are using the EV, you know for 20 or 25 kilometers it is going fine, and after that you need to recharge it. So that is beforehand it will have the prediction or accurate prediction that we are having the charge is going to be shortage in between this time of the day. So I can prepare myself beforehand, and then I can avoid the situation. Suppose I want to go for it 100-kilometer drive, and every 25 or 30 kilometer I need to recharge. So that will be hectic for me. So before, if I know that in this location, when I am reaching this location, there will be a charge shortage. So I will find out the rechargeable stations, and I can go and do the recharge. Or else I will find out in my 100 kilometers journey how many EV recharge stations are there, and what will be the suitable location for me to charge. So that is the accurate prediction. Then is your adaptive learning. In case of adaptive learning, we'll find out how the charge estimation is done, or you can say after 25 kilometers, there is a signal is showing you, you need to find out next 5 kilometers or next 10 kilometers a recharge station. So from the environment it is learning. So that is the adaptive learning situation. State of the health estimation. So it is finding out the degradation of the battery life, and it is going to find out what is the current health of the battery and how many days it can survive, or what are the measures you need to take. So that is the state of health estimation. In anomaly detection, that is basically the fault identification in the battery and real-time monitoring you can do. Then optimization of charging and discharging, the smart charging, like we have discussed, uh, whether load is more or not, or what are the points we need to recharge, or if there is a length of 30 kilometers you are going, then you are increasing the load on the battery. So that is the optimization and charging and discharging. Predictive maintenance, basically the maintenance scheduling within 10 days or 15 days, you need to go for a maintenance, or it is providing you the prediction that your battery's lifetime is this. This is the current health of your battery, and this is the SOC, or you can say the state of charge estimation of your battery. So considering all these points, you need to go for a scheduled maintenance on this day. So that is your predictive maintenance. And also it is going to reduce your cost, because beforehand you are having a complete details of your battery, and accordingly you can plan that how to manage the battery life, how to go for the estimation of the battery health, or how to find out the failures present or the faults present, and how to optimize the battery. So it is basically at the end going to reduce the cost of yours. So these are the key application in the EV where the AI ML can be implemented. And this is just an example how basically the AI ML is going to work in the EVs. So we are having battery of arrays, or you can say in number of batteries are present in a particular array. Then, or you can say these are the data set. So all these batteries, suppose in our location there are 100 or 1000 EVs are there. So all these 1000 EVs battery is one input to the data set. That's why it is the battery arrays. And here we are doing the data pre-processing. We are eliminating the noise present in the data. Data means your battery. And what is the feature of each of the battery? These are the features, like your state of charge, your state of health, and the optimization, your you can say the load on the battery. These are the features of all these data sets present. So for every 1 to n battery, we are having certain features like we have discussed in the previous slide. All those features along with the battery name or the battery number are the data present in the data set. Taking that data set, we are going for the processing or pre-processing. Pre-processing, we are going for the noise reduction, and then we'll have the AML algorithms to find out what is the prediction. Suppose you are going for the load management prediction. Then it will data n batteries, and what time of the day the load is more, what time of the day the load is less, and how the load is approaching. So these are the features we are taking from for the load management. Then we are training a data set, and whenever there is a new vehicle is coming, or the same kind of vehicle also, we can predict this time of the day there is very high load, so you need to reduce the load. That is your prediction part. And if you are going for the accuracy also, you can show the user, suppose 80% it is accurate, or you can say the health of the battery is now 80%, you need to go for certain less load so that the accuracy of your vehicle will be increased. So that is one example how the state of the health estimation is done. Similarly, you can go for other features like optimization. You can go for your predictive maintenance, cost reduction. These are one applications how the AI ML is going to be implemented in the EVs. Okay, so these are the techniques and models we are basically using for the EVs. The first one is the machine learning algorithms, like we have seen the regression model, the classification models. Then also we are using the deep learning. So you can say all these terms I have written here, like machine learning, deep learning, reinforcement learning, data fusion. So ED is basically a combination of all the technologies. So what is the requirement of EV, and accordingly we are going to implement any of the technologies. Suppose you are going for your load management. So for load management, you need the previous log data or the historical data is required. And for historical data, you know, the recurrent neural network is the best one. If you are going for any image kind of data, suppose batteries, all the end batteries images are only present, and I don't have any kind of data which part of the day the load is high or low, only the battery images are present. Then how can I predict the health of the battery? So I use this CNN, convolutional neural network, to predict the health of the battery in the EVs. So for all the images, you will use the CNN. For the historical data present, you will go for the RNN. And if you are going to take the input from the environment and then predict, then you will use the reinforcement learning. And data fusion, sometimes suppose you are going, you are climbing a hilly area through your EV. So that time, sometimes the past history is required, sometimes the environment condition is required, then we'll go for the data fusion techniques. So these are the implementation areas where we'll go for multiple techniques and also the combination of the techniques we are going to use. And these are the real life examples and the case studies which Tesla, General Motors, Toyota, and NIO, they are working on the EVs. Tesla, you know, this is the pioneer in the market for all the electric vehicles, and it is basically improving the state of the health and the state of the charge estimation and optimizing the charging processes, because lithium battery is used for all your EVs, and the lithium is very less available in the world. So now the next project for Tesla is how to replace the lithium battery with the aluminum battery, because aluminum is everywhere. Like if you say in India, 60% of world's aluminum is produced in India. So for us, it is the best opportunity if the EV's lithium battery can be replaced by the aluminum battery. It is going to provide us the cost or the monetary benefits, as well as the environment is going to be good, and the heat whatever we are feeling nowadays, that is also going to be reduced. So they are working on this aluminum battery replacement. And why the aluminum battery is going to be beneficial, because we don't have to go for the recharging there, we'll replace the battery. So nowadays what we are doing in the EVs, in the station of the charging stations, we are going, and for suppose 25 minutes or 30 minutes we are doing the charging, or maybe 15. They have reduced, initially it was half an hour, and then now it is reduced to 15 to 10 minutes for the recharge. So the time whatever is consumed in the recharging process is the disadvantage for Tesla. So what is their concern now? If we are replacing the lithium battery with the aluminum battery, then instead of recharging, we can replace the battery. So we'll not use or we'll not use the time for recharging. We'll go to the recharge stations. Already rechargeable batteries are there. We'll give our battery which is not don't have the charge, and we'll take the batteries which are already charged. And in that time, maximum 1 or 2 minutes can be done. And instead of 10-15 minutes of rechargeable time, we are reducing to 1 minute only. So that is their next task, how to replace the lithium battery with the aluminum battery, and Indians are going to be benefited by this replacement a lot. So that is the optimizing charging process. These they are working, and maybe within 1 or 2 years it is coming to the market, and enhance overall battery performance. Obviously, it is going to enhance the battery performance. Similarly, General Motors, they are working on self monitoring or your SOS, predicting the battery life and enhancing the safety and reliability. And Toyota Research Institute, they are developing only the ML models to predict the battery degradation and the life cycle of the battery. Similarly, NIO, they are using the AI to manage the battery swapping stations and monitor the battery health. So they will predict in this 10 kilometers or 20 kilometers, there is a battery rechargeable station is there. You can just swap your battery, and suppose I am initially taking one direction, and after that I have some other work, I'll move to any other, not in that particular direction, I am changing the direction. So in that direction, how many rechargeable stations are there, it is going to predict and show me on my screen that you are having this many stations. Suppose I had 5 kilometers or 10 kilometers, so that it will be easy for you. So NEO is working on that. So these are the case studies or the real life examples how these 4 companies, they are working on the EVs. And autonomous driving is another part of your EV, because on this also research is going on, how to replace the driver with the autonomous driving. So for that, we are having the sensors, the cameras, the radar, the lidar, and the GPS. Anyone, what is the lidar? We know what is camera, we know what is radar, what is GPS, what is the lidar? So basically, lidar is you can say, it is the extension of the radar, and through the you can say the light, it is going to find out the output. So there will be, you can say, the sensor lights will be there, and it is predicting how the EVs are moving through the lights only. So you don't have to identify the vehicle itself. If the light of the vehicle is present, then through that only it is going to find out. So this is how the combination of all these techniques, we are going to go for the autonomous driving inside the EVs. And these are the levels of autonomy present in the autonomous driving. So all of you must heard about the Google self-driving car. So this self-driving car is coming under your high autonomous or high automation. Sorry, high automation. So no automation means driver related. Driver is going to handle it, all your EVs. And driver assistance means driver need to be present there. But if there is a requirement, it is going to, the driver is going to take the step. So for example, if you go for your car, when you are doing the smart parking, the sensors present in the car, it is showing you this is the limit of the parking, or you can say some object is present behind, you just stop. While you are moving backward, you just stop there. That is your driver assistance. Basically, driver is going to continue, but there is some assistance by the AIML is present there. And partial automation is basically, it is providing you, suppose you are going for, all of you have seen the autopilot mode. So this autopilot mode in the aeroplanes are coming under your partial automation. Driver need to be present there. Sometimes it is going to be taken by the autonomous driving, and sometimes the pilot is going to operate. So that is your partial automation. Conditional automation is basically for a specific kind of road. Suppose it is a hilly area, this driver can take, or the autonomous driving is going to take place. So this is only for a certain conditions you can go for the autonomous driving. High automation. So high automation, the example I have given, Google self-driving car, where driver is not required. The devices or the sensors present in each part of the car is going to identify the input and the environmental condition. Then there is a communication between all those parts, like your how you are going for your communication between the gear and the steering. So all these things are happening through the protocols only. So that is your high automation. And full automation, till now this part is not developed. It is under research, full automation, and how the implementation will be done, that we do not know, because in market it is not available. So in case of EVs, the next target is the autonomous driving, and in these 5 levels of autonomy, they are going to provide the autonomous driving. And what are the key technologies for the autonomous driving? We are having the sensors, we are having the software and algorithms, like your perception algorithm, your localization algorithm. So localization is basically finding out where your vehicle is. Planning and control and connectivity is your protocol communication. So like I told you, the gear is having one setup, as well as your steering is having, your brake is having another setup. So how the communication between these chips are happening, that is your connectivity, and which is called as your vehicle to everything, V2X communication. Like we are having V2I, vehicle to infrastructure communication, vehicle to person, V2P communication. Similarly, every communication is coming under this connectivity. That's why it is vehicle to everything communication. And these algorithms are finding out where your car is basically, or your vehicle is, and which route you need to take, how to control the vehicle, and what is the perception of that vehicle. So everything is done through the software and algorithm, and these are the input or the hardware. Through the hardware we are taking the input, and this is how actually it is working, the autonomous vehicles. So it is finding out the detection part, like your lane detection, your object detection, object tracking, free space detection. So ahead, if there is some objects are present, or in behind your car something is present, which lane you need to take for this direction. And localization, all of you have seen the GPS, how the GPS is working. Then planning. In case of planning, we are having the route planning. So suppose I am having a EV, and the rechargeable time is suppose 30 kilometer. Within 30 kilometer, I have to recharge. So what is the best possible route I need to take so that I will reach my destination before the recharge need to be done? So that is your route planning. Then behavioral planning, how the battery is going to perform, and this is your trajectorial planning. And then all this combined, we are going to control the EV through simple control, and this is your MPC is your predictive control, multi-predictive control, how multiple kind of prediction provide you the output. So these are the three technologies how we are going to uh, use the autonomous vehicle inside your EVs. And also in EVs, we are going to do the energy efficiency. So these four companies, they are basically working on the energy efficiency, because we have seen the renewable energy. If non-renewable energy we are using, and definitely it is going to be someday it will be over. So for that, energy efficiency is also required. So these are the case studies and examples how multiple companies, they are working for the energy efficiency of EVs. This is also one direction of research, like Tesla, they are designing the AI powered autopilot and full self-driving system. And then Nissan's Leaf EV. So this uses the AI for the smart route planning, like we have seen how the route can be planned. And BMW's i3 and i8 models, they are basically the AI-driven systems for regenerative braking and the energy management. And Waymo's autonomous EVs utilize the AI for route optimization and efficient driving patterns. So is one, or you can say multiple research areas are involved here. And if you want to work on this, you can check in Google, all their documents are available, and you can go through what are the AI algorithms they are using, and how the communication between multiple algorithms are happening. So all these things are present in the document, and it is publicly available also. And this is one example how the route optimization is done. So these are the uncontrolled first phase. There is no control of AI. Separately, we are going for the charging, and we are finding out the stations, and then we are going to do the charging. Second phase, we are having the AI system operator. So this system operator is not AI enabled, so it is working through its own software. But if you go for the AI enabled software, and also it is present in the cloud, so anybody can be retracted through the cloud based AI system operator. They can find out which direction you are taking, and where the charging stations are present, how far it is from the power grid, and what is the demand of the charging station, whether it is renewable energy based or non-renewable energy based, and accordingly it can predict to the EVs that this route you can take, or After 5 kilometers, if you take this route, then after 5 kilometers, you are having a recharge station, and this recharge station is on the renewable energy, and what is the demand of your EV, and accordingly whether it is fulfilling or not. So this is the system operated. Next one is the third phase. This is indirectly controlled charging and discharging. So here the pricing is involved. Same thing what is in the second phase, but the pricing demand it is showing here. So suppose you are going for 5 kilometers and the demand of your EV is this, and it is renewable energy. Then what is the price and whether you can afford it or not, that also it will show you. So this is the third phase, how the route optimization is done, and accordingly the prediction would be done, and the driver, if it is a driver based, the driver is going to take the decision. If it is autonomous vehicle, similarly the machine is going to take the decision which one I'm going to take. So basically this third phase is for autonomous vehicles in the AV, because no driver is present. So seeing all these pricing and the demands, the machine is going to find out the output or decide which route I need to take and how I'm going to proceed for that. And this is energy efficient routing, that is the fleet management. So fleet management, I think all of you know how multiple brokers, they are connected to the EV management, or you can say there are multiple companies are present, and each company is managing the EVs, and for managing the EV also they are charging. That is basically the fleet management. So what are the techniques present in the fleet management? Vehicle tracking and telematics. The GPS tracking of the vendor's task is to track the vehicles and find out the telematic systems. Similarly, maintenance management, whether predictive maintenance you are going to do or preventive maintenance you are going to. Driver management, self-driving or your driver is associated with that. Then fuel management, optimization strategies, route optimization, like we have seen the dynamic routing or the load optimization, compliance and reporting. So this is for the report generation and parts. So in case of fleet management, there are multiple companies present, and each of the companies, they are having n number of EVs. So they are providing to the drivers these EVs, and accordingly sitting inside their company, they can do all these 6 tasks there. So where the EV is going, whether it needs any recharge or any maintenance, how the driver is going to manage, whether fuel is required or not, or how it is doing the route optimization, everything sitting inside their home, they are going to calculate, and finally they will generate the report. This is one high-end, you can say, case study, which is called your fleet management. And the last part of this talk is the integration. Like in the initial slide, I told you we'll discuss renewable energy separately, we'll discuss EV separately, and finally we'll merge EV with the renewable energy. So how EVs are going to be merged with the renewable energy? If you have seen this diagram here, renewable energy field, everywhere it is written renewable energy field, not the non-renewable energy field. Why? Because we have seen in the renewable energy, it is really important to use the renewable energy rather than the non-renewable energy, because we have seen the environment condition, how it is drastically changing. So for EVs also, we need the renewable energy. That's why we'll integrate EV with the renewable energy, and we see how AIML can be implemented with the integration of EV as well as the renewable energy. So these are certain application areas where we can implement or we can integrate both EV and renewable energy. So charging infrastructure, suppose your charging stations. So there we'll go for the on-site renewable energy generation. So we are keeping the environment condition there, and the energy is going to be generated there. Then we'll go for the smart charging stations. So any vehicle can come, and then through the renewable energy they will charge. Vehicle to grid technology. So that is your bi-directional charging and grid stabilization. So for charging infrastructure, we are coming to the charging station through our EVs to recharge. In case of bi-directional charging center, anywhere in the world, the vehicles can recharge themselves. No need a no need of any your recharge stations, because sun is available, wind is available, and water is available. So how we can use those uh, energies directly to our EVs? So this is the one research area where people are nowadays mostly working, vehicle to grid technology or bi-directional charging. Then demand response program. Here the time of use pricing. Suppose you are using the charging station for 5 minutes, then what is the pricing? So accordingly, you can go for that. Vehicle energy management system, that is your smart charging algorithms, predictive charging. So all the machine learning algorithms we have seen, the RNN, the CNN, your regression model, classification model. So everything can be implemented here. Fleet electrification. So for the fleet management, we have seen how they are going to manage sitting inside their own company. So that is your dynamic routing planning, renewable power fleets. So all these things are the areas where EV and renewable energy can be integrated with the help of the AI. So this is one example how EV charging ecosystem based on the renewables. So see, the morning they can use yes. Okay, so morning they can use their homes for the EV charging because it is available, and daytime in between the workplace they can charge, and evening also in the home. And this is the report generation. You can see the report how it is generated, how you are going to use the renewable energy in the EVs. And these are certain challenges of consideration. Hello.
Yeah, madam, carry
Is
on.
my
No
voice?
issues. Yeah, madam, carry on. No
So
issues.
these are these are certain challenges. So we have already seen how to integrate EV and renewable energy with the help of the AI and ML technologies. And while we are implementing, these are the key points we have seen how the fields can be done and what are the technologies we can implement. For that also, we are having certain challenges. Which challenges nowadays the researchers are feeling or finding when they are integrating using the AI/ML? That is the intermittency. So what is intermittency? Uh, because the solar and the wind power both are available always, but the timing of availability is a crucial point. So which is intermittent. According to the available timings only, we can go for the EV charging. Suppose you are using for your EV the solar energy, and suppose the solar panels are not recharged, you are completely dependent on the sun to recharge that one. So suppose for 7 days or 8 days there is the cloudy weather is there, so how you will go for your EV recharge? So that is the intermittency. This is one of the challenges we are facing nowadays for the integration of EV and the renewable energy. So it requires the effective energy storage and management solutions. So you need to uh, have enough storage of the renewable energy. Otherwise, conditions can come and we will not able to use our vehicles. Infrastructure requirement. Whenever you are going for the scaling of the renewable energy and the EV charging, then it needs the grid upgradation, the charging station upgradation, as well as the storage upgradation. Then policy and regulation. Already we are having the charging stations of renewable energy, sorry, the EV charging stations. But when you are going for the integration of EVs, they need to be upgraded. Similarly, the storage systems are also need to be upgraded. So that is another challenge. Third challenge is your policy and regulation. So you know better that everything need to have a regulation and a policy. So whenever you are integrating both EV and renewable energy, those policies need to be, uh, you can say, upgraded, or time to time there need to be changes in the policy. So that is also another crucial point. And the third one is the technological integration. So all the energy storage system, energy sources where we are going to implement the AI/ML technologies, the integration of technologies of the renewable energy as well as the EV need to be compatible, because there need to be communication between the charging station as well as the EVs. So that compatibility need to be there, and sometimes there is no communication present between the or you can say between the renewable energy stations as well as the EVs. So that is also another major point. So that's why it is written standardized communication protocols need to be there. Now EV is having different communication protocol. Renewable energy charging stations are having different communication protocol, and sometimes they are not compatible with each other. That's why we need to have a standardized communication protocol. So these are the future directions of research when we are going to combine both EV and the renewable energy. So if anyone is having any questions for discussion, you can ask on the EV. And the integration of renewable energy in the field of AI and ML.
Participants, you can unmute your mic and ask directly to the expert. Okay, yeah, thank you, madam, for accepting the invitation from your busy schedule and delivering a wonderful talk. So now I request all the participants to please turn on your camera so that we can take a snapshot. Madam, please can you turn on your camera also? Yeah.
You have not given access to camera.
Okay. So thank you all. Thank you, madam.
Thank you, sir. Thank you so much.
Yeah, well, yeah. So feedback form has been shared in the chat box. Participants, you can please fill it out.
Sir, can I leave?
Yeah, sure.
Next session will start